So as I was saying, yeah, so it checks to see if it's an adult, and then it stops, so it validates it. Now the problem with the code that I have over here is that if I want this thing to be number of students now, they're not an adult, then I have to get the functions that I have for valid number of students, and copy that one over there and recompile my code, right? You understand this? I cannot reuse this getInt for different things. Either I have to write another function and call the getInt in it, or I have to recompile the code. That's bad. I don't want this. We have a solution for that. And the solution is this. Question. When I have an array, people, how is an array created? When I say integer A5, what happens? I create an integer in the memory, right? An array of integers in memory. And give me a second. I cannot do two things at the same time. So when I say integer A5, 5 integer gets created in memory, and A is a pointer pointing to the beginning of that chunk. Is that correct? Are we OK with that? OK. Now, this is what I want to tell you. I have these two functions, right? What does it mean? Let's analyze it. When you compile this code, what happens? If I write something like cout, not cout, sum of 10 and 20 or 30, what happens at line 11? It goes to the function, passes the two values to the function, and function runs one. And when it ends, it comes back and goes to the other one, right? Now the second function is called. When you compile this, all these things become binary and executable, right? When you run the program, what happens? The executable goes to the memory, correct? So essentially, all these stuff are in the memory, correct? Take a look at this. What are those two numbers? They are the address of where the executable code is in memory for functions sum and prod. So as array's name hold the address of the beginning of the integers in memory, a function name holds the address of the beginning of the executable in the memory. So the function, the array name is the pointer. The square brackets in front of it is an operator that whatever value you put, it gets added to the address, right? So the function name is a pointer pointing to the executable, and parentheses in front of it means go to the address, passing the arguments to that address. So the parentheses in front of it are just operators. It means call, go to, execute. So if I could, in here, create a pointer that can match that. If you look at the two functions, sum and prod, they have exact same signatures, right? So I wish I could write over here void func ptr int and int. That's the exact same integer, right? How can I make this damn thing not to be a function prototype, but a variable, a pointer that is capable of holding the address of any function that returns void and receives two integers? We would say, OK, when you want to create a pointer, you put an asterisk beside it, right? So let's do that. If I put an asterisk beside it, then the damn thing is not a pointer. It becomes just a function that returns a void pointer. So what you do, you tell to the compiler, hey, the asterisk belongs to the name, which means now I have a pointer. So funcPTR is just a variable capable of holding the address of any function that returns a void and two integers. For example, that. I'm repeating a value. So now in here I can say funcPTR. Let's call it fPTR. FuncPTR is too long. fPTR is equal to sum. Now fPTR 100 and 300. Oh, too much. 10. 110, OK? Or 30 and 40 and 10, something like that, OK? And I'm going to copy that, copy, paste, paste, paste. Prod, repeat. So what happens? I'm saying fPTR will hold the same address as sum. So when I say fPTR 4010, sum will be called. If I say fPTR is prod, now fPTR 4010, product will be called. Repeat, repeat will be called. So if I run this program now, you'll see that 3 different functions are called, like that. Not only that, I can do this. Now I have an array of 3 pointers, and I'm going to set it to sum, prod, and repeat. Now I can say for integer I, set to 0, I less than 3, and I plus plus. And I can say over here fpi, and in here I can say 20 and 3. Three functions are called. Are we OK with it? Let's go to a new line. What the heck are you doing? New line, new line, new line. That's better, OK? So essentially, fp0 becomes sum, fp1 becomes prod, fp2 becomes repeat. Are we OK with this? I have, yes. And returns a void. That's it. No other one.
I'm not really seeing why we would trouble.
Give me 2 seconds. Trouble? This is the most, when I understood this, like the first time, this is actually has nothing to do with C++. This is C. This is IPC 144. OK, and when I found that out, it was like heaven opens its door on me. And I'll tell you what. You know how much? Give me 2 seconds. So time. Oh, 1 minute. Shoot, I'll explain the next time you're coming in. Yeah. I'll explain the next time you're coming. So E, A, B, C, D, E, F, E, A, B, C, D, E, A, B, C, D, E. Where is F? I, where did I come from? E, F, G, I? What is G function pointer? Okay, so the next day you're coming in. By the way, can't do two things for concept. I can do one concept and one thing. So in one shot you do all the concept, the next shot you do all the programming. For the test, midterm. Okay? So I'll do it in 2 times. One, you come for half an hour, 40 minutes, you do the concept questions only, concept and walkthrough, and the next time you're coming, you do your programming. I'll send you announcement. I'll send you the announcement when is it going to be maybe we can do the concept after the break. So no, I'll do the concept after. I'll do the concept after the midterm. So you do your programming before midterm, concept after midterm. Because it doesn't take much, concept doesn't take much time to mark. Programming takes time to mark. So no, it's got to be less. Let's go, we are late. Bye-bye. See you guys later. Have a good day, guys. I'm not going to say if you have any questions, we don't have time to answer. I'm always late, and it's a shame. Let's go.